Hi, I'm Tanish, and this is part two of the series where I solve systems of equations with matrices with different methods. In this video, I'm going to use inverse matrices to solve them. Okay, so let's get into solving matrices with inverse matrices. Obviously, for this method, you have to know how to find the inverse of matrices. Otherwise, it's not going to be viable for you. I You'd have to augment the system of equations, but it's quite different from before. And so instead of converting into like an augmented matrix, you make this into a matrix equation. So what that means is I just take all the coefficients in this system of equations. So in this part of the system equation, I take all the coefficients and make that into a matrix. So I'll do that. It's the first one is 1, that's 5, 2, and 3. And then I make a separate matrix. This one will be a 2 by 1 matrix where I just have x and y, and then I'll have another 2 by 1 matrix equal to this. It'll be 14 and 7. Now, if you'd like to think about this is the same thing as this. Because if I were to multiply these matrices, this is essentially what it is. So this matrix times this matrix. If I were to multiply these matrices, I'd end up with 1x, 5y, 2x, 3y, and that'll be equal to 14 and 7. And then we could just revert it back into systems of equations. It'll be x plus 5y is equal to 14. 2x plus 3y is equal to 7. So this proves that these two things are the same thing. So that's why you convert it into this form. Oh, and now we do our solving. So this equation is just similar to a normal equation that you have. So think of this as like a coefficient, and this as the variable, and this is what it's equal to. So let's say I have 3x is equal to 6. This is the coefficient, this is the variable, this is what it's equal to. The coefficient, the variable, and what it's equal to. Now, how would you solve this equation? Right? Normally, you just divide by, you divide both sides by 3, right? So you just divide by 3. So x would equal 2. Well, you obviously don't know how to divide matrices. So, well, what dividing is essentially just multiplying by the inverse, right? So instead of dividing, we could multiply by the inverse of 3, and the inverse of 3 is 1 over 3, right? So 3 times 1 over 3 is 1, so 1 over 3 is the inverse. So if we multiply this both sides by 1 over 3, then we'd still get the same result. X is equal to 2. So that's what we got to do over here. It's the same thing. We have to multiply both sides by the inverse of this matrix so that we can isolate the variable. So this is what I mean by converting this entire matrix into converting this systems of equations into a matrix equation itself. So first, obviously, we gotta turn this into you gotta find the inverse of this. So let's do that. So let's say that this matrix is equal to A. So 1, 5, 2, 3. And A inverse would be 1 over the determinant of A. So let's quickly solve that. So it's 3 minus 2 times 5, which is 7. And then this will be the adjugate, which will be switching these two. So there'll be 3, 1, and then and these will be the negative of these. So it'll be -5 and -2. Oh, my matrix is a bit it's a bit weird, but forget about it. We have our inverse. I mean, if you want, you could like solve it out, or like make it into fractions, but I prefer keeping it this way because it's much simpler to look at. So this will be our inverse of this matrix. So how would you go about it? So obviously we'd have to multiply both sides by the inverse. Now this part you have to be careful, alright? So let's say we multiply, let's say we have this. We have a times xy, which is equal to 14, 7. Let's say we were to multiply this side by a inverse. Now, you have to multiply the other side by a inverse. But here's the issue. Where do I put a inverse for this side? Where do I put it? Well, you might be saying it wouldn't matter, right? But it does. Because if you multiply matrices, the order matters. So if I put it in the wrong place, I will get the wrong answer. I mean, if you want to think about it logically, we did multiply this a by a inverse when a inverse is to the left of a, right? So we have to put a inverse onto the left of this matrix. If you do think like that, you're correct. So that's a good way of looking at it. So since we multiplied a by a inverse to the left, you do the same to the other side. So you multiply a inverse to the left. If you do it the wrong way, well, you won't even get the right answer because it's unsolvable. Because it's 14, oh, 14, 7. Because this matrix is a 2 by 2 matrix, right? This is a 2 by 2 matrix. B3, negative 2, negative 5, 1. Now this is a 2 by 1 matrix, and this is a 2 by 2 matrix. The number of rows in this doesn't match the number of columns in this, so you won't be able to multiply it out. Always be careful at this step. Now let's solve this out. A inverse times A is well, what happens if you multiply A inverse times A? So if these are matrices, you get the identity matrix. The identity matrix for a 2 by 2 matrix is 1, 0, 0, 1, right? So let's put it up 1, 0, 0, 1. Now, what's the definition of identity matrix is that if it's multiplied by another matrix, I mean, if it can be multiplied by that matrix, it ends up being that matrix. So this is possible. This is a 2 by 2 matrix, and this is a 2 by 1 matrix. The number of rows matches the number of columns. So this will end up being x, y. This is A inverse 14, 7. Now let's actually finish this off. And this is the easy part. 1, negative 7. And then 3, negative 5, negative 2, 1, 14, 7. Alright. I think the best option would multiply this constant over here onto this one because it's easily divisible. And since it's a scalar, it really wouldn't matter when you would multiply it. So I would suggest multiplying it now so that you can make the multiplication between these two much easier. So let's do that real quick. Um, x, y, 3, oh, negative 5, negative 2, 1. This will be negative 2, negative 1. And now let's solve this. X, y is equal to 3 times negative 2 is negative 6. Negative 5 times negative 1 is 5. And then negative 2 times negative 2 is 4. 1 times negative 1 is negative 1. And then we solve this out. We get x, y is equal to negative 1. And this y and 3. So this is x is equal to negative 1. y is equal to 3. And that's our answer. I don't really prefer this method because inverses are just is it's tough on its own, but applying it to systems of equations just makes it more annoying. Because inverses of a 2 by 2 is just really simple, but once you get like into higher dimensions of matrices, it'll just simply get harder and harder to just find out. You'll end up making more mistakes. So I'd suggest using the other either of the other two methods, which it'll be much better.